Electronic Specifier.
Welcome to Electronic Specifier Insights, the podcast for electronics engineers. I'm your host, Paige West. In today's episode, I speak with Wim Van Thillo, CEO and co-founder of Pharrowtech. Pharrowtech spun out of IMEC in 2018, and I speak with Wim about the vision behind the company's founding and how its team's expertise in telecommunications and semiconductors has shaped its approach to millimeter wave technology. We hope you enjoy this episode. Let's get started. Today, I'm pleased to be joined by Wim Van Thillo, who is the CEO and co-founder at Pharrowtech. Thanks very much for joining us. How are you today? Are you well?
I'm good, thank you. How are you?
Yeah, I'm not too bad. Thank you very much for asking. So why don't you tell us a little bit about yourself and your background before we get started?
Sure. So my name is Wim, co-founder and CEO of Pharrowtech. I'm an engineer by training. I did electronics engineering, also got a business degree in parallel. After my university degree, I did a PhD at IMEC, which is an R&D center headquartered in Belgium, on wireless communication, not really on chip design, but more on algorithms, so digital signal processing. And that was actually already on the topic that we are now commercializing with Pharrowtech. So that goes back a long time. I started that PhD in 2005, which is ages in technology terms, if you think about it. After my PhD, I stuck around at IMEC in different roles. At one point, we started a project on automotive radar, which was not a communication system, but similar in terms of technical background. Became very successful. After that, I led a couple of teams in IMEC in different capacities. And then in 2018, we had a commercial opportunity to take part of the R&D that we had performed, part of the IP, spin it out and create Pharrowtech. And that's, how the story got started.
So can you tell us, about the vision behind starting the company and sort of how your team's expertise in telecoms and semiconductors have shaped your approach to the technology that you offer?
Yeah, indeed. So the vision has remained remarkably unchanged since almost 20 years now. And that was all wireless communication that we use today, or essentially all. There's a really tiny fraction which uses other techniques, but almost everything uses electromagnetic waves, radiation, to convey information from A to B. And that means you need spectrum. You need megahertzes, gigahertzes, whatever you want to call it, to convey information. And since we have been consuming roughly 50% more data year on year since the early 80s, it's a continued trend. You need more of that spectrum. Sooner or later you run out. And what we found when we started this work at IMEC is that there was a lot of spectrum available at 60 gigahertz, very high frequencies at the time. You couldn't really achieve those with regular technology back in the days. But there was tons of spectrum available. And we wanted to build technology that could use that massive amount of spectrum to do wireless communication by the time it was needed. And that has been the vision since then. And that is still the promise of the technology today. Massive amounts of bandwidth.
Mm. And millimeter wave RF technology is sort of the heart of Pharrowtech solutions. So what makes your technology unique and how does it compare to existing connectivity solutions out there, such as, fiber or traditional wireless options?
Mm-hmm. Well, yeah, so the big difference between fiber and wireless is, of course, the convenience of deployment. So fiber, once it's there, it's unbeatable in terms of throughput and power consumption, and even operating costs. But the problem is putting it there, right? So depending on where you are in the world, connecting a house or a business with fiber costs between 1,000 and 10,000 euros. Without exaggeration, all the permits, the digging, the deployment, the connecting, all that stuff. So the capex of rolling out fiber is enormous. And that is the big advantage of wireless technology. So that's the advantage of wireless versus wired. And then the advantage of millimeter wave versus a traditional wireless is again that bandwidth. So we can, in a single chip, process 14 gigahertz, 4 gigahertz of bandwidth. That is more than everything else combined. And that's what gives you these super high throughputs, high data rates. Yeah.
Mm-hmm. So why did you choose the 60 gigahertz spectrum? How does it enable scalable and cost-effective solutions?
Mm-hmm. Well, probably the most important element there is regulation. So these bands have been allocated to unlicensed use, such as Wi-Fi. So all the Wi-Fi that you use today is unlicensed. You don't need a spectrum license to operate there. Everyone can deploy and manage networks, as opposed to, for instance, cellular networks where an operator needs to buy a very expensive spectrum and can then manage that for a couple of years. So that is the main reason these 14 gigahertz are available almost worldwide in all the important geographies. It's available today. And the reason why it was allocated to this kind of unlicensed use in the first place is that at least the lower part of that band is not very favorable for long range communications. Without going too technical, there's a fraction of that band that gets absorbed by oxygen molecules in the atmosphere, which means that you cannot go very long. But for many applications, you don't need that long range, so you can just use it for short range Wi-Fi like applications.
Okay, and following on from that, then let's talk about some of these applications. So, how is your technology transforming 5G fixed wireless access to achieve, the fiber-like speeds and low latency? What are some of the standout deployment examples?
Yeah, so maybe first of all, 5G is licensed. You can use 60 gig, which is unlicensed band, in a 5G system. It's a bit like unlicensed LTE. But the use case where we see most traction today is using a different waveform, IEEE 802.11ad but probably no need to go into detail. But we see a lot of use cases, and it really depends on the geography and the strategy of the operator deploying. We've seen 60 gigahertz fixed wireless access networks being rolled out in dense urban environments like in LA in the US. We've seen it deployed successfully in suburban areas in South Africa. And even in very rural areas in the US, you have tons of WISPs, wireless internet service providers, who use these frequencies to offer high-speed internet access in really rural areas with very low user density. And it's been deployed successfully in all three of them. So there's a lot of use cases, yeah.
And what about for things like AI and big data? How is your technology contributing to applications like that?
Well, it all fits in this bigger trend of more data consumption, right? In the past, let's say 5 to 10 years, that has mostly been driven by, let's call it, high resolution visual content in general, streaming video, live video conferencing, video games. It's all graphical data, let's say. And now, obviously, with AI, we all know training an AI model requires a lot of data. And then also afterwards using it, it's a lot of data that you're shuttling back and forth to the cloud. So to keep this trend going, connectivity is needed. It's the lifeblood of communications, if you will, of technology. So we do see this trend continuing, regardless on whether the AI sits in the edge or in the core or whatever. There will be a lot of data going back and forth, and this kind of technology can continue driving that trend.
Mm. And speaking of things like big data, I'd like to chat about sort of some of the IoT applications. So what sort of role does the company take in enabling things like safer smart cities? And are there any sort of examples that you can share of successful implementations for smart cities?
Yeah. So often IoT is used synonymously for these very low throughput devices that send a couple of bits every now and then, typically like, I don't know what, electricity meters and that kind of stuff. So for this kind of IoT, our technology is not relevant, but it is very relevant for, let's say, machines, devices that generate a lot of data or that consume a lot of data, and especially those that need it in a very low latency fashion. In the context of smart cities, we do see a couple of use cases that generate a lot of traction. One is definitely wireless CCTV networks. CCTV density keeps going up, more cameras being deployed, the resolutions keep going up because, often, seeing the detail, makes a difference between having a useful system and a useless one. So resolution keeps going up. And also often you don't want too much compression on these video streams, because with compression you might lose that specific detail that you do need afterwards. And that means tons of data. And again, these cameras are often in places where there's no fiber. So that wireless CCTV deployment is an interesting use case. Another one that we've seen is autonomously driving vehicles in the broad sense, could be buses, trains, but also eventually robo-taxis. They generate a lot of data too. The data needs to go somewhere, needs to go into the cloud for processing. And there also this technology is very suitable. So it's a bit different use cases, but similar in the sense that it's always about these high speed data streams that need to go somewhere. And then obviously also smart cities. Well, if you call it fixed wireless access, it's a city service, of course. It's enabling your citizens and your businesses to use high speed internet. So maybe fixed wireless also fits a bit in that context.
And millimeter wave technology also has applications in things like virtual reality, TVs, home networks. So I'm interested to hear what innovations you're excited about in sort of consumer electronic space, and what role your technology is playing in shaping sort of that side of things.
Yeah. On the short term, it's definitely getting rid of the HDMI cable. If you think about it as a consumer, it's the final cable you're likely to use at home. Apart from a charging cable, to be clear, power is still best delivered via cable, although it can be done wirelessly too. But still, HDMI cables are still ubiquitous. And the reason is simple. It's just too much data to transfer with regular Wi-Fi or Bluetooth or whatever wireless standard. So getting rid of that cable, having a desk without cable clutter, having a TV that you can use, that you can connect flexibly to with a gaming laptop, having a high-end VR headset for gaming. These high-end headsets, they are still cabled, not just at home, by the way, but also in professional context. A lot of VR is used for professional training, for instance. A lot of use cases get at least a lot more convenient and sometimes also enabled by a wireless connection. So that HDMI cable, that is definitely step one, where we also already see a lot of traction. And then further down the line, standardization has just started in IEEE to include the frequencies that we use in regular Wi-Fi, so standard Wi-Fi. Today, your Wi-Fi system uses normally 2.4 gigahertz and 5 gigahertz. In some places in the world, 6 gigahertz has added a bit of capacity to that. But we are now on a track to standardizing the use of 60 gigahertz, adding 14 gigahertz of bandwidth to standard Wi-Fi. And that's obviously, that's opening completely new possibilities also for regular Wi-Fi. And that is in the end also where I think the real breakthrough ubiquitously of millimeter wave will happen.
And following on from that, there's a big global push at the moment for digital inclusion. So how does Pharrowtech sort of prioritize addressing connectivity challenges in the underserved regions compared to the urban deployments?
Yeah, in underserved regions, it's often that capex, that capital expenses that limit the deployment of fiber. So many places in the world will never be connected to fiber, not because of technical reasons, but because of economic reasons. It just doesn't justify the cost. As I said, it's between 1,000 and 10,000 euros. So these people are left behind, and their fixed wireless can bridge that gap. You can in a very, very low cost way deploy a network, which is still orders of magnitude more dense than, for instance, what you can offer over Satcom. Sometimes people think Satcom is the answer. It really is not. So look at the map of Starlink. The whole area in London is sold out. Its capacity is maxed out. It gets nowhere close to the density that you need to offer high-speed internet in moderately populated areas. So that is really a technology that closes that gap. Also, the deployments that we see, for instance, in South Africa, they're offering internet services to people who live on $1 a day. It's magnificent. So it's a great use case, and it does close that digital divide. Yes.
And given all you've said so far, then what would you say are the biggest challenges to the widespread adoption of millimeter wave technology, and how are you looking to address them?
One is definitely, or historically has been, complexity. The propagation of the signals is very different from below 5 gigahertz. You need beamforming, for instance. The high frequency aspect makes it much more difficult. The chip design, the antenna design, everything is 10 times harder because the signal is just lost so easily. So it all requires very intricate and well thought through design. And that is, of course, something that we address by we build products that so the antennas, the chips, that encapsulate that complexity. So we shield, let's say, our customers from that complexity, so they can integrate our solutions into their product, tapping into this massive spectrum without having to master all that complexity themselves. So complexity definitely has historically been limiting deployment. And the second thing is cost. It just, because of these high frequencies, it used to be very expensive to build systems. So there have been military radar systems offering at several gigahertz high operating, I mean. And it was perfectly fine to use gallium arsenide, gallium nitride, compound semiconductors for that because volumes were small. Now we really need to build a technology that can scale in the millions. And there we have an edge without, again, with again, our engineering expertise. We build systems using pure CMOS chips. So that's the super high volume semiconductor technology, nothing fancy, nothing exotic about that. Our antennas, our packaging all use organic laminates, standard technology. We use only high volume test solutions, so nothing expensive there. So that cost aspect has also been eliminated now. So with that, I think we have the two main hurdles cleared. The complexity, we shield our customers from that. The cost, we only use high volume materials and techniques. So I think we're ready to scale it.
Fantastic. And since your launch in 2018, the company's achieved some rapid growth through various partnerships and various funding rounds. Can you elaborate a bit more on sort of the key milestones you've achieved and what you think has driven this success?
Yeah, sure. So I think if you take a step back and look at the company, we've had roughly, let's say, three phases. The first one, which indeed started at IMEC a long time ago, was really hardcore technology development, where we just had to prove that this vision was possible. The vision of using this kind of high frequency ubiquitously at low cost. So we've had a lot of technology development with very basic, like building power amplifiers in CMOS, low noise amplifiers, building an oscillator, piecing it together into a small system, building a beamformer, steering 4 antennas, steering 16 antennas, scaling it up, integrating it all onto one single chip. And that technology development, the moment you build one chip that works in a lab, you're happy. So because you've proven that fundamentally it's possible. From there, let's say we went into more, once that technology fundamentally was proven, we went into real like product development. What does this technology have to look like to address the customer's problem? So we started developing the current chip and the antenna specifically for outdoor deployments with a couple of hundreds of meters of range, make it testable in high volume, make it well documented, make it easy to absorb by the customer, both hardware and software. So a lot of technology of product development, let's say, that was roughly the period between incubation and today. And now, while everything is ready, the technology is there, hardware, software, collateral support, the field trials, it's all come together, and now it's really a matter of commercially scaling it. So we're going back into yet another big phase with the company where we're ramping up the volumes. We're serving more customers in more geographies with more different use cases. So it's all about making it a commercial success now.
Well, following on from that then, what would you say going to be the company's priorities for the next, 5 years in terms of sort of technology development and market expansion?
Well, the priorities are pretty simple. We're a startup. We're a small team, so we like to keep things simple. First, it's indeed generating that business traction with the current chip and the antenna for the use cases that we've discussed. Outdoor, it's mostly fixed wireless access, backhaul, point-to-point links. Indoor, it's getting rid of the HDMI cable in different use cases. Initially, we're targeting so-called prosumer applications, so professional users, because that's where initially there's a bit more value, and then you can spend a bit more engineering time to develop the solution that is required. So that is priority number one, scaling the business with the current chip. And then priority number two is making sure we stay in the lead for that Wi-Fi adoption. So again, standardization started, IEEE 802.11bq. Pharrowtech is a leader in that standardization, and it's all about keeping that lead up to, let's say, 2028 when this technology will hit the market.
And as co-founder and CEO, what would you say motivates you the most about the mission that the company has?
Well, first of all, what is the mission? We summarize it in one sentence. Our innovative wireless platforms simplify and accelerate the adoption of millimeter wave technology. And for me, what excites me most is that simplify and accelerate. That is really the core of the matter. Again, it's a complex technology. The engineering is quite challenging. So we need to, shield our customers from that complexity. We need it simple to make it simple for them to adopt and use and deploy. And the second part, acceleration, it's been long in the making. The use cases are there. In order to keep that lead, we really want to go fast and help our consumer, our customers in the way they need to make this business happen and connect their users and serve them with this solution. So in terms of a mission, it's about that: simplify, accelerate. Next to that mission, we've also defined 4 core values. They're pretty simple. Customer first is number 1. We're a very engineering heavy company. We're aware of that. Sometimes it is no longer about technology and product development. It's about helping a customer. So customer first is the most important there. Happy to go into the others if you still have time, but that's the short answer.
No, that's perfect. Thank you. I mean, my last question was going to be if you wanted to discuss anything else, if there's anything you think I might have missed or any final words you'd like to share with our listeners.
No, I think that's a good summary for the company in a nutshell. I think especially those listeners who have been familiar with millimeter wave, they've seen that it has a long history. The adoption in 5G definitely has had its ups and downs. 5G in general hasn't really had always the momentum that was hoped for. But I think especially with millimeter wave and especially also with the standardization to include it into Wi-Fi, that momentum has been found. And we look forward to staying in the lead in this technology and bringing it to all your listeners in the near future.
Oh, brilliant. Well, thank you very much for your time today. It's been a pleasure having you as a guest, and thank you for introducing us to Pharrowtech and telling us a bit more about your mission. And I look forward to seeing the company grow over the next couple of years.
My pleasure. Thank you for having me.
Thank you for listening to this latest episode of Electronic Specifier Insights. Don't forget to subscribe to the series to keep up to date with our newest guests, and do share with fellow colleagues, friends and family who may be interested in the latest news from the electronics industry.
Electronic Specifier.